Hello again. We are continuing our discussion on polynomials by talking about how to multiply polynomials. All right, so I want you to think of area, and area is length times width. So I want you to think in terms of length and width as that little distance there being x. If it's red, it's a negative x. If it's a given length, we're going to call it 1, and if it's a given red length, we're going to call it negative 1. So for example, 5x minus 3 times 2x plus 7, I'm going to set that up as a length and a width of a rectangle. And the length is going to be 5x minus 3, and the width is going to be 2x plus 7. So, yes, one polynomial is the length. So if it is 5x minus 3, then I need 5 of those x lengths, and I need 3 of the negative 1 lengths. That makes up 5x minus 3, or 5x plus negative 3, same thing. The width is 2x plus 7, so I need 2 of those x lengths, and then 7 of those positive 1 lengths. That makes 2x plus 7. And so now I've got a length and a width, and I just create the rectangle and find the area of it. And so there's my rectangle, and all of the little lines that I've created have made squares, big squares, little squares, or rectangles. And so each of the big squares is x by x, so that's x squared. If it's red, if it was a red square, then it would be negative x squared. So if I was multiplying x by negative x, a rectangle is going to be x. If it's a positive times a positive or a negative times a negative, x times 1, it could also be a negative x. That's going to happen in this picture. And then we have little squares that could either be positive 1 or negative 1, depending on the signs of what I am multiplying. So all of those big squares are positive x times positive x. And I've got 10 of them, so that is 10x squared. Then after that, I've got negative 1 times positive x for those rectangles, and so those are 6 negative x's, and so I'm going to write that as negative 6x. Then, working on the next part, I've got rectangles that are positive x times positive 1, so those are all positive x's, and I've got 35 of those. You can count them if you want. And then at the very last, I've got little squares that are positive 1 by negative 1, so that makes them all little negative 1 squares. And so my total area is 10x squared minus 6x plus 35x minus 21, and that simplifies. The x's in the middle can be simplified to 29x. So I actually have 10x squared plus 29x minus 21. That's the area of the rectangle. That is also what I get when I multiply 5x minus 3 times 2x plus 7. So if you're not comfortable with that way of multiplying, there are a few other methods we can use. I'm going to talk about the horizontal method, and what I'm going to do is I'm going to draw an arc from each term in the first set of parentheses to each term in the second set of parentheses, which means I need 4 arcs. Okay, so there's 1, there's 2, there's 3, and there's 4. So each term in the first set of parentheses has now been connected with each term in the second set of parentheses. All right, so what I'm going to do is I'm going to multiply each pair of terms and see what I get. Well, the 5x times the 2x joined by the red arrow gives me 10x squared. The 5x and the 7 joined by the blue arrow gives me plus 35x. The negative 3 and the 2x joined by the purple arrow gives me negative 6x. And the negative 3 times the 7 joined by the green arrow is negative 21. Again, I have like terms in the middle, so my answer is actually 10x squared plus 29x minus 21. All right, so that's another method to do it, if that's what you're comfortable with. The vertical method is a lot like when you multiplied just regular 2-digit numbers together. All right, so you remember what you did there. You multiply the last term in the second row by everything in the top row, and then you would keep moving along that bottom row. So if I multiply the plus 7 by the negative 3, I get negative 21. Multiply that same positive 7 by 5x, and I get 35x. Then I move to the 2x, which is in the second row, and I multiply it by everything on top. So 2x times negative 3 is going to give me negative 6x, and then 2x times 5x is going to give me 10 x squared. So it's the same concept. Everything in the second row is going to be multiplied by everything in the top row, and I'm going to add it all together. So when I do add it all together, I get 10x squared plus 29x minus 21. So same answer, just a different method. And then lastly, I'm going to show you the box method. This is my favorite. Students really like this method. You've seen it before when we were multiplying monomials by polynomials, so we're going to use it with this one. So each term of one polynomial is going to go at the top, so the 5x minus 3 is going to go there. And then each term of the other polynomial is going to go at the left of each row. And I'm just going to multiply whatever's at the top of a column by whatever is at the left of a row and keep track of that in those little squares there. All right. So the 5x and the 2x multiply to give 10x squared. The 2x and the negative 3 multiply to give negative 6x. 5x times 7 is 35x. And 7 times negative 3 is negative 21. And again, I have to add the like terms. The 10x squared is fine by itself. Then the 35x and the negative 6x gives me 29x, and then the negative 21 stands alone. So once again, my answer is 10x squared plus 29x minus 21. So there are several ways for you to multiply polynomials together. If you have any questions, please let me know, and I will see you tomorrow.